Okay, so cool. Just at the whiteboard, we did this entire problem as we could do it at Essex County College without using a calculator. But again, I do encourage you to learn how to use a calculator. I want to go back over it now. This one I would actually whip my calculator out and finish the problem off. All right, so I want to do the first thing, which is I'm going to do go to Sage, which is my calculator. I'm going to reset. I'm going to define a function, g of x. Before I do that, I want to do a variable, and the variable is going to be x. Let me put down g of x, and g of x is equal to x cubed minus 14x minus 27 over x plus 2. All right, the next thing I want to do, go back over here and evaluate a g at f of x when x is 5. So I have to look up here. When x is 5, f would return 34. So I want to do g of 34. And I get this crazy looking number. If you want to approximate, which is what they're asking you to do, you get this number over here. So again, using a calculator, that's what I'd get for A, part I of A. Now the next one, that was pretty easy to do. We already did at the whiteboard. Letter B. Yeah, letter B, let's put this one down, solve. And it's going to look a little strange to you when I do this over here. You're going to be shocked what happens over here. Solve, g of x equals 3. G of x equals 3 for x, and then I get this thing over here. It's kind of hard to read, by the way. So what I want to do is I want to plot it, P-L-O-T, and I'm going to plot g between 0 and 10. All right? You may wonder why I'm doing that. I'm just giving it a range. Whoops, I lost it there. And I'll see what it looks like. Now looking at it, this is what g looks like between 0 and 10. And looking at it, I'm going to say it looks like 3, the root of it would be between 4 and 6. So I want to go back to this thing, and I'm going to find root now of g of x minus 3. That the root means it equals 0 between 4 and 6. And what number do we get? 4.87. So if I did g of that number, I'm using the underscore for that number, by the way, it should return 3. And it does. It's really close. All right, so I got that part done. All right, now we did that. Determine the end behavior. Let's go back to Sage. That's limit, L-I-M-I-T. G of x goes to infinity. And infinity in Sage is just the two O's together looks like an infinity. That's infinity, as we did, by the way. We already did that. Now, C is probably the worst thing in the problem set, but what I'm going to do is I'm going to define a data set. And I want to point out what data set we're defining over here. And it's 1 minus 10 is the first data point. 2 minus 5, 3, 4, 4, 17, and 5, 34. All right? And then what do you do? Well, I got to model this thing on this data set. And let's do that. So I'm going to do that model thing. I got to define some variables over here. So A, B, and C are variables. I'm going to say the model. To me, it looks quadratic. I'm not sure if it is, by the way. I know it's not linear. The next thing I'd say is probably quadratic. It does appear to be growing, all right? So put that down. And then I'm going to, I got to remember. Sometimes I can't remember, and that's a problem. I know it has something to do with data, defining variables A, B, and C for a quadratic, and then modeling the problem. And I'm going to, find fit. Data set and the model. And that's my recollection. All right, let's see what happens. Well, I'm getting the A, I'm getting the B, and I'm getting the C, by the way. So what does this mean? F of x is equal to, the A would be, I'm just copying those numbers, by the way, x squared, minus the B is minus 1. Now, you remember when I did this thing by hand, using a difference method, I got the same thing, except I didn't get all those padded zeros over there. I got 2x squared, minus x minus, and that minus 10.99 I said was minus 11. So Sage is doing a really good job of approximating the model, by the way. All right, using this over there. Now, if you did this over here, f of, let me go back to these things over here. F of 1 should be around minus 10. I get that. F of 2 should be around minus 5. I see that. F of 3. You notice how nice it fits, by the way. And really, this data they're giving me is quadratic, by the way. It's going to be 4, and f of 4 should be 17. I'm seeing that, and f of 5 should be Sorry about that. Should be 34. All right. So again, that last question, if I were doing it and I didn't do that difference thing, and I was trying to explain this over here, I used the table, I modeled it. I would look at it and say, it looks quadratic at that point, and then I would use Sage to model it, and I'd say it's a perfect fit. The quadratic really is a perfect fit for it. That's the reason I would kind of give. But again, I want to point out, it depends who's teaching these courses. We don't teach data fitting at Essex, by the way. But the bottom line is that difference thing I showed you in the whiteboard, it really does work nicely for this data set, by the way. Thank you.